Okay, so take a moment to pause the video and write this down. Okay, so we've seen already the idea of say a local min and a local max. But if you look at this function, okay, it doesn't continue to the left and right, it just stops. It goes from A to B and that's it. This is the lowest point of the function right here. Okay, so we would call this the absolute min, and the absolute max is actually up here. It occurs at we'd say an endpoint. What else can we say about this diagram? Okay, you'll notice that this absolute min is also a local min, but that's less important. Okay, so the actual definition of a say a local max, we'd say f of c. Well, let's do a min here. So let's talk about this c value right there. F of c is a local minimum. Nope, not local. Absolute is the absolute minimum of f if f of c is smaller than, it's the smallest it gets for x in D. We usually call domain just capital D. Okay, that's the formal definition of an absolute minimum. Absolute maximum would be the same idea, but you change the sense of the inequality. Okay, so let's do an example. F of x equal to x squared. The absolute min is, well, f of 0 equals 0. So we're talking about the basic parabola here, right? So here's our absolute min right there. And there is no absolute max, right? Because over here I haven't restrained the domain at all. Okay, so this function can get as large as I want. And then something like f of x is equal to x cubed, where the graph is this, something like this. Okay, just by looking at that, I can see there is no absolute max, no absolute min.